Welcome to Math 8. Does a sequence always have a pattern? Before we answer this, we first need to define sequence formally. Have you encountered fill-in-the-blank problems such as this, or maybe this, or this? Yes, they are examples of problems that involves sequence. Sequence is an enumerated collection of objects like numbers, symbols, shapes, and many more. But what is the difference between set and sequence? When you are in grade 7, you define set as collection of objects. And we just define sequence as also a collection of objects. So what do you think is the difference between the two? In a set, repetition of an element is not allowed, while sequence, repetition of an element is allowed. Also, in set, order is not important. However, in sequence, order is important. Let me explain it further. So in sequence, you can have the element of your sequence as 5, 2, 6, 2, 8, and 2. Take note that 2 is written more than once because in a sequence, repetition is allowed. However, in a set, repetition is not allowed. That's why you can just write 2 once. Another difference between a set and a sequence is on the ordering of the elements. In a set, for instance, you have the set whose elements are 2, 4, 6, 8, and 10. This is just the same as the set with the elements 10, 8, 6, 4, 2 because the order is not important. Notice that even you are going to change the order of the elements in your set, this will not be considered as another set. On the other hand, in a sequence, if you have the element of your sequence as 2, 4, 6, 8, and 10, it is different from the sequence whose element or terms are 10, 8, 6, 4, 2 because here the order is important, which means changing the order of the elements of the sequence will give you another sequence. We have two important types of sequence, the infinite sequence and the finite sequence. For infinite sequence, it is a sequence with continuous number of elements. From its name, infinite sequence, it has infinite number of elements. So the number of elements for this sequence cannot be counted. For instance, we have 2, 4, 8, 16, 32, 64, and so on. But instead of writing the other terms, we used to write these 3 dots. These 3 dots is also called ellipses. On the other hand, we have the finite sequence. Finite sequence is a sequence with countable number of elements. This means that its number of elements can be counted. For instance, we have 2, 4, 8, and 16. So there are 4 elements in this sequence. To define sequence formally, let us make a table for the sequence 2, 4, 6, 8, and 10. Now we write the elements of our sequence as our a sub n. So we have 2, 4, 6, 8, and 10. The n value of our a sub n represents its order in the sequence. For instance, since 2 is the first term, its n value is 1. Since 4 is the second term, its n value is 2. Since 6 is the third term, its n value is 3, 4 for 8, and 5 for 10. Notice that the n value are the set of natural numbers from 1 up to 5 because it is a finite sequence. But in case of infinite sequence, the n value starts from 1 up to infinity. Also notice that the values in your n cannot be repeated, which means that this table represents a special type of relation, and that is a function. I am sure you are very familiar with the term function since you discussed it in a previous grade level. In a function, the values in the first row represents the domain, while the values in the second row represents the range. Now, I want you to remember all the facts that we learned here. We learned that the table represents a function and the domain are the set of natural numbers from 1 to 5 for finite sequence and 1 up to infinity for infinite sequence. We are now ready to define sequence formally. For the formal definition of a sequence is a function whose domain is a finite set 1, 2, 3, up to n, or the infinite set 1, 2, 3, and so on. Or simply, it is a list of objects like numbers, symbols, shapes, wherein you can label them as first, second, third, fourth, and so on. Does a sequence always have a pattern? So what do you think is the answer? Is it a yes or a no? The correct answer is no, since the definition only requires us to have a domain starting from 1 to n or 1 to infinity. In other words, a sequence need not to have a pattern. They are a set of elements ordered so that you can label it as 1, 2, 3, 4, and so on. Today, we defined sequence. We compared set and sequence. We also differentiated infinite from finite sequence. We also explained if a sequence needs or need not to have a pattern. Now it's your turn. In your activity notebook, please answer the following questions. Number 1, explain the difference between set and sequence. Number 2, does a sequence always have a pattern? Explain why. And number 3, give 3 examples of sequence with a pattern and explain the pattern. This ends our session. I hope you learned something today. God bless and stay safe, everyone.